Fall feet first into a black hole and your toes pull harder than your head. Stretch that effect across an entire star, and you get one of the most violent processes in the universe. Spaghettification is the tidal disruption of an extended object by a strong gradient in gravity. The near side accelerates faster than the far side, so the body elongates into a long, thin stream. Cross the tidal radius, the distance where tidal forces overwhelm self-gravity, and the star is no longer a star. It becomes a gas filament wrapped around the black hole's path. Roughly half the stream is bound and falls back over weeks to months. The other half is unbound, gaining enough energy to escape on hyperbolic orbits, high-velocity ejecta. Differential acceleration scales as 2gm times delta r over r cubed. The cubic dependence is why the inverse square sun feels gentle but a black hole shreds you in the last seconds. The bound stream returns and self-intersects, dissipating energy and forming a transient accretion disk. Newly luminous gas radiates a tidal disruption event flare in the UV and X-ray. Peak luminosity reaches 10 to the 44 erg per second for a few months, then fades as the T to the minus 5/3 power. Real TDEs include ASA, SSN, 14 Li, AT2, 019 DSG, and AT2, 018 highs. Here is the twist. Only smaller supermassive black holes shred stars visibly. Above about 10 to the 8 solar masses, the Schwarzschild radius exceeds the tidal radius. The whole star is swallowed before disruption. TESS spotted a TDE every few months by chance. Could LSST and Roman push that to 10,000 events a year, mapping the dormant supermassive holes nobody is currently feeding?